Hey everybody, welcome to Armchair Technician. Today we're going to be taking a look at what many consider to be the mother of all bass amps, the Ampeg SVT. We're going to get into that in just a second, but first, a little bit of history. Introduced in 1969, the Ampeg SVT, or Super Valve technology, was the first bass amplifier in history that produced enough power and volume to accommodate the ever-increasing demands of rock and roll. Despite many cosmetic changes over the years and added features such as graphic EQs and switchable impedance selectors, the fundamental design of the all-tube SVT has remained largely the same. Today we are taking a look at a 1997 SVT2 Pro. These amps are a pain to work on and a beast to haul around, but when they are at their best, they can deliver the bass tone of the gods. Okay, so we've got the bottom panel pulled off of this SVT. One thing I wanted to say is that there are going to be a lot of screws to keep track of. This is just what I've gotten from taking the bottom panel off. And there's the rack mount screws in here too. So what I'm going to do is put them in individual baggies just so I can keep them straight. And I'm going to mark everything, like where it goes, where it came from, because it's really easy to lose track of what screws went where, and you've got a ton of other stuff on your workbench, and this is just the easiest way to keep everything organized so you don't lose anything. Another thing I like to do when I'm disassembling an amp, especially one that has so many tubes, is I like to keep track of where each tube was placed when I removed it. So this is the first preamp tube I've pulled out. It was in this position here. So I'm going to put a little piece of painter's tape on each tube and just mark the position that it was in, so I can place them back in the exact same position that they were removed from. That's something that can also help you identify problems, such as if there's a problem with one of the tubes and that's what's making the amp act up, then you can more easily identify which tube that is if you know where it came from and where it's going back to. Okay, so we've got the preamp board pulled out. You can see it actually all looks pretty original. I don't think any of these components have been changed out. There's a date sticker here that says April of 1997. So this amp is about 21 years old, or at least the board is. So what I'm going to do is check these components here, this electrolytic capacitor, and then there's a couple more of these radio lead capacitors here that I'm going to test, as well as this big resistor here. I'm going to start there. I'm also going to turn the board over because these amps are notorious for having problems with cold solder joints, which anytime you've got a pressed circuit board like this, over time any of these solders, especially around the tube sockets like these here, what I'm going to do is take the iron and just run the solder on all of these connections just to make sure that they're good, the connections are there, and then we'll see where we're at. Okay, you can see that this capacitor is bulging out at the top. That's never a good sign. This is on the positive end of the capacitor, which is where the higher voltage is going into. This actually tested within the range of tolerance for the value that it's supposed to hold, but I went ahead and changed this out because this is an original part. So it's, you know, it's over 20 years old now. So that is right here on the board. I also pulled off one end of this resistor just because it looks like it could be a little crusty, but this was within value as well, so I just left that in there. These other two caps right here actually appear to be fine. I'm not going to test them. What I did do, however, is reflow the solder on each of these joints that are in the preamp tube sockets. So that's all of these that you see, the little circles on the board. There's a total of 5 of these. Here, here, here. I didn't really add solder. Well, I did to a couple of them, but not all of them. I just melted it and made sure that it was getting a good connection. I also did the same to all of the solder joints that are going to the pots here on the front part of the board. So just to make sure we have good connections on all of these major parts here. Okay, I went ahead and yanked the other two boards as well because I have determined that I don't think the problem in this amp is with the preamp. I reinstalled the preamp board and I turned it on. It was doing the same thing that it was doing before. The customer said he thought it was the preamp, but I'm thinking now that the problem is actually in the power amp, because the amp works and it sounds like it's supposed to sound, but it's not getting any volume or any volume to speak of. So I went ahead and pulled out all of the main board, which is this one, and then this is the little board that all of the power tube sockets are on, and it clips into the main board with this ribbon cable here. So we're going to start and go through this thing one set of components at a time. So this is the main power section of the board. These are the capacitors that deliver all the power to the tubes and the output transformer. Now it might be a little hard to tell in the video, but these here, all these green ones, are slightly rounded out at the top. This is not a good thing. They're supposed to be flat and smooth across the top like these. This just means that they're old and they're going to start leaking if they're not already leaking, and they could, I guess, possibly explode one day. But what we're going to do is definitely replace these 5 caps. They're all the same value, and that's where we're going to start. Also, we have these 2 resistors here that look suspect to me. This one, it's hard to see in the video, but this one has a big crack across it right here. So definitely going to replace these 2. These are going to the heater power supply. One thing that you need to have, especially when you're working with pressed circuit boards and you're trying to remove components from the board, you need to have some sort of desoldering tool. This is the one that I use. There's a few other types. They all have their strengths and weaknesses, but it's very important to use one of these tools in order to pull the solder away from the board so you can remove the component. Having a tool like this just ensures that you get good, clean removal of the old component from the board. And if you don't use something like this, the chances of you damaging the board in the process are pretty high. A little closer up, this is what the tool looks like. This is commonly referred to as a solder sucker. How this works, this tip has a little hole in it. You set that over the solder joint that you want to remove while depressing in this rubber bulb. You can hear the air kind of coming in and out of it. So you depress the bulb. Obviously this thing is heated, it's plugged into the wall. Depress the bulb, hold it over the joint that you want to remove until the solder melts, and then you let go of the bulb and it sucks the solder up into the shaft here. And then you take it on a metal surface, squeeze the bulb a couple times, and it'll push that solder back out onto this surface. It actually works pretty well. These are fairly cheap too. I would say under $20 you can find one of these. It takes them a long time to heat up, but they work pretty well for what they're designed for. And we're going to do one extreme close-up of this technique just for illustration. So we're going to depress the bulb, hold it over the joint that we're trying to remove. It melts the solder. You release the bulb and you squeeze the solder back in to your some kind of receptacle that's not going to melt or be damaged by hot solder. It's that simple. Alright, so we've got those 5 capacitors out. 1, 2, 3, 4, 5. I wanted to give you a shot of those holes in the board here where the capacitors were soldered in. We got these cleaned up pretty well with that solder sucker. It takes a little bit of time. Sometimes you have to use the tip of your soldering iron to soften it if it's got a lot of solder on it or something. Sometimes it needs a little help. But these look really good, I think, and we're going to be able to put in the new caps without any problem. This is what one of the old caps look like. You can see it's got a lot of dirt and grime on it. I can only guess that this amp must have lived somewhere where people smoked a lot, because under normal conditions it wouldn't look like this. Also, this kind of glue stuff that's on the side, amp manufacturers glue the caps down to the board just to keep them from, just to secure them a little better, I guess. It's a pain in the ass to work with, but I guess it kind of holds them in place better than just a regular solder joint. So here's a couple more shots of all the grime and goop that is inside of this amp. Pretty crusty. We're going to start installing the new capacitors in this amp. Now they look virtually the same. You have to be sure and get the right size as far as the height, the diameter, and the lead spacing, which is the distance between the 2 poles on the bottom. Sometimes this is a challenge to find the exact size of a capacitor to fit this particular board. Also, more importantly, is that you line the capacitors up correctly. Now on these, this white line is the ground. So make sure that you put the ground in the right spot. That's the only white line that's on the whole thing, is right here. And also, to help you line everything up correctly, the board actually has this plus sign next to each little circle where the cap goes. Obviously, that is the positive side of the capacitor. So make sure you get these lined up. If you don't, catastrophic things can happen. And we have these new capacitors installed here. And this is the underside of the board. You can see all of the solder joints that we did. Let's see, starting with here and going across here. And these two here, and these two. I marked all of the positive sides on the back of the board. You can see obviously the little plus signs here. Just for whoever opens this thing up to work on it again, this is going to indicate where the 400 plus volts of DC current is going to be on the board, so we can be careful and not electrocute ourselves. And we also got these 2 resistors swapped out here. Alright, so we've got this thing mostly put back together. I ended up also replacing a couple of the screen grid resistors in the power tube circuit here. One of them was completely wide open, meaning that it had an infinite amount of resistance. It wasn't passing any current at all, so that definitely had a bearing on the level of volume that the output was at. I also set the bias control, which is really cool on these amps. They have 2 different controls. This one on the left controls the left 3 tubes at the top, and this one on the right controls the other 3. So ideally, when both of these lights are green and stay green, that means that the bias level is correct between the tubes, and it actually kind of tells us that the tubes are functioning fine as well. But this is a nice feature of these SVT heads. Okay, the amp is turned on, the high voltage is on. I have this shop cabinet plugged in. So as you can hear, the amp itself is really quiet. What I'm going to do is plug in this shitty shop bass that I have right here. The bass itself is really noisy, but we know that the amp is actually pretty quiet right now. It's not making any buzzes or noises. But we are going to play a few notes through this just to make sure that everything's cool. So I'm going to plug this in, and you're going to hear it start to buzz. It's got a little bit of a... I can't really turn it up much louder than that in my apartment. Mainly because this cabinet is only rated at about 150 watts. The head is 300 watts. So obviously I don't want to blow up my speaker cabinet, but I can see that the amp is functioning normally, or it seems to be. So I'm going to leave it on for another hour or two just to make sure nothing weird happens. And then I think we can call it a day on this one. We got this amp back up and running. Okay, that wraps it up for today. As always, thanks for watching, and we'll see you next time on Armchair Technician.